Hi guys, just a quick note on properties of linear functions. The first thing we're going to look at is the general equation of a line. So y is equal to mx plus c, where m tells you the slope. The bigger the number, the steeper the line. If the number is positive, it slopes upwards. If it's negative, it slopes downwards. And we should already know that parallel lines have the same gradient. The plus c is where it cuts the y-axis, i.e. the y-intercept. Okay, so if you are going to refer to the slope and the y-intercept, then you must make sure that the equation is in the form y is equal to mx plus c. Okay, so if it's not, you'll have to rearrange it, and you're going to need to remember to make your y coefficient equal to 1. Okay. Straight line graphs, we've got horizontal and vertical lines. The vertical lines have the same x coordinate for each point on the line, so therefore we refer to them as x is equal to whatever the coordinate is. So in this situation, it's x is equal to 6, because on every point on that line, my x value is always going to be 6. For horizontal lines, it's the same idea, but this time we know every point on the line is going to have the same y, and it's going to be y is equal to -4 for this blue line. Remember that the equation of the x-axis is y is equal to 0, and the equation of the y-axis is x equal to 0. The gradient of a line, so we know that the gradient of the line is equal to rise over run, or y2 minus y1 over x2 minus x1. So in this case, if I was trying to find the gradient, I would first of all have to label my points. So if I label my A points x1 and y1, and if I label my B points x2 and y2, and then I can plug them into my formula. So in this case, I'm going to end up with 8 take 2 over 12 minus 0, which is equal to 6 over 12, which is equal to a half. So the gradient of this line is a half. Remember your general formula, m is equal to y2 minus y1 over x2 minus x1, so make sure you have that one. The next one we're going to look at is the midpoint of a line segment, so the midpoint being halfway between the two of them. So in order to do that, we're going to work out the mean between the y coordinates and the mean between the x coordinates. Okay, and remember that the midpoint of a line is going to be a point, so it has to have coordinates x and y. Okay, so again, label your points. My A is going to be x1, y1, and my B is going to be x2, y2. Okay, and then you can just plug it in for the formula. So for the y1 and y2, if I'm finding the mean of them, I'm going to have to do 2 plus 8 divided by 2, which is equal to 5. And for the x1 and x2, their mean, I'm going to do 0 plus 12 all over 2, which is equal to 6. So I can say straight away now that this point here, m, is going to have the coordinates 6 and 5. Okay, so the general form for midpoint is you're trying to find the mean of the x and the mean of the y, so it works out to be in brackets x1 plus x2 all over 2, comma y1 plus y2 over 2. Distance between 2 points, again, my first step is to label my points, so x1, y1, and x2, y2. Okay, when we're actually using this formula, we can see straight away that there's a right angle triangle if I'm studying the rise and run between the 2 points. Okay, so this actually makes a right angle, and that's why we use Pythagoras' theorem. So this side here becomes the hypotenuse, okay, because it's opposite the right angle, and then we can see the hypotenuse squared is equal to the square of the sum of the square of the other two sides. So Pythagoras' theorem tells us that the AB squared is going to be equal to the run squared plus the rise squared, or AB squared is equal to x2 minus x1 squared plus y2 minus y1 squared. And don't forget to square root it afterwards. So in this example, my rise, which is my change in y, is going to be y2 minus y1. So my y2 is 8 minus my y1 is 2, and I get 6. If I do my change in x, my run, I'm going to have x2 take x1, which is 12, take 0, which is equal to 12. And then I can plug that into my formula. So 12 take 0 squared plus 8 take 2 squared, and I get 144 plus 36, which is square root of 180, which to three significant figures is 13.4. So the distance of that line AB, rubbing out my hypotenuse, the distance of the line AB is going to be equal to 13.4, correct, to three significant figures, and the general form is d is equal to, where d is the distance, is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So a couple of other things that you need to remember. The equation of the line with a gradient m that passes through the point x1 and x1, y1, sorry. So if you know the gradient and you know a point x1, y1, then this is the formula that you're going to use. So y minus y1 is equal to m on x minus x1 if you know gradient and a point, and then you can rearrange it to work out your y-intercept or your c. If you are asked to find the equation of a line through 2 points, you would use the 2 points first of all to find the gradient, and then you would plug it into this one using the gradient on a point. If two lines are parallel, then they have the same gradient, which we've already discussed, and if two lines are perpendicular, then the product of their gradients is -1. Okay, so m1 times m2 is equal to -1, product being times. Okay. Also just a few things about perpendicular bisector. So if a perpendicular bisector cuts a line segment exactly in half by crossing it at right angles, how would you find the perpendicular bisector of AB? So you're actually trying to find that point. And we already have these skills. Give your answer in the form... Oh, sorry. Perpendicular bisector means we're trying to actually find this line. Sorry, we're trying to find our red line. Okay, so we already have the skills, and we want to write it in the form ax plus by plus c is equal to 0. Okay, so the first thing you're going to do is find the point. That's what I was trying to think of. So to find the point, you're going to do the midpoint formula, and you get 6, 5, because we've already worked these out. To find the gradient, we've already worked it out as a half. If you find the gradient of the perpendicular, it's going to be the negative reciprocal of a half, so that's going to be -2. Okay, so now we know the perpendicular bisector has a gradient of -2 and goes through the point 6, 5. So we've already found this information. We found that it has a gradient of -2 because it's perpendicular to AB, and we found that it goes through the point 6, 5 because it meets it at the halfway point. Okay, so now we can work out by plugging it in, our gradient and our coordinates into the equation. So y minus 5, because what's y1 is 5, is equal to -2, which is my gradient, on x minus 6, because minus 6 is my x1. Okay, and then I rearrange it in the form ax plus by plus c is equal to 0, and I end up with y minus 5 is equal to -2x plus 12 when I multiply in my -2. So when I multiply in my -2, I end up with -2x plus 12, and then I can rearrange that below. My -2x comes over, it becomes positive. My y is already there, and my plus 12 comes over to become minus 12, leaves a total of minus 17. And it's now in the form ax plus by plus c. Okay. Last thing that we need to know about linear equations is that the gradient of any line is equal to the tan of theta, where theta is the angle between the line and the positive direction of the x-axis. Okay, so this formula here, the positive direction of the x-axis, we're referring to this line here, and the line itself, so this theta is the angle between them. So tan theta is equal to opposite over adjacent, so we already knew that. Tan theta is equal to opposite over adjacent, so I can talk about my opposite as my rise and my adjacent as my run. So it's i.e. the change in y over the change in x, which is equal to rise over run, which is our gradient. Okay. Find the angle. So if I was asked a question, I'd find the angle that the line joining -3, -2 and 1, 0 makes in the positive direction. These are the steps that I need to follow. Okay. So I'm going to first of all work out what the gradient is using my 2 points, because I know that the gradient is equal to tan of theta. Okay, and I'm trying to find the angle. So I'm going to say that m is equal to, y2 minus y1 over x2 minus x1. Okay, so I'm going to label my points, x1, y1, and x2, y2. Okay, so plug them in, and I get 0 minus -2. Watch out for your negative signs. over 1 minus negative 3, okay, which is equal to 2 over 4, which is equal to a half. So I know that the gradient of my line is equal to a half, and I know that m is equal to tan of theta. So if I know, therefore I can say that a half is equal to tan theta, and if I'm trying to find my angle, I can do the negative inverse of tan a half, which is going to give me theta, and I get theta is equal to, and when I plug that into my calculator, I get theta is equal to 26.6 degrees, correct to 1 decimal place. Okay, so these are the kind of questions that you're going to have to answer using your skills and applying them. Okay. So write down what you would do. I think this is a really good exercise if you actually just have a think about what you would need to do. I'm not asking you to solve questions, I'm just asking you to think about what you would do if you had these questions. So to decide if two lines are parallel, what would you need to work out? You have to work out their gradients and compare them. To decide if two lines are perpendicular, same idea. So have a read through these 10 things and see if you would be able to answer the questions. Okay, good stuff.